Okay, so we are about to start now analyzing the regression models. And to do that, I will focus on the locus of control and happiness because there's going to be models for every variable, but I will do the examples with locus of control. So to do that, you go to analyze, and then you go to regression, and then you go to linear regression. And in here, you have dependent and independent variable, which you need to fit. So you start with happiness on dependent, and then locus of control on the independent. And this is the first model that we are going to do. We are going to, before you click that, you go to statistics, and then you click on collinearity diagnostic. That's the only thing you have to change, and then you click OK. So this is the first model. We're going to do 3 models, but the first one is only locus of control and happiness. So this is the outcome of that. And now take notes because you need to kind of report these 3 things. The first thing is that you need to report the model fit. You need to report if the model fit is significant or not. So to report that, you need to check if this number, the significance, is below 0.1. So in here, it's very good, is 0.001. That means that's very good. So we passed the first test. Our model fit is significant, so we move forward. The next thing that you need to check is the collinearity, the multicollinearity that we ask. We don't have a problem in here because we only have one variable. Multicollinearity means that in our model, we try to explain if the differences of happiness are explained by the differences of locus of control. That's basically what the regression model is doing. But here we only have one variable, happiness and locus of control. But in the next models, we're going to have more variables. The multicollinearity will tell us if there is a problem that these variables are the same variable, just in different numbers. So for example, imagine that we ask for age and year of birth. That is the same thing. You are asking it twice. That will pop up the multicollinearity issue. So if that happens, it will pop up, and it will pop up here, the BIF value. The BIF value should never be higher than 4. That is something that you should also take notes or remember. First note this, the significance of the model, and second note, the multicollinearity test. It shouldn't be higher than 4. Here, of course, we don't have a problem because we only have locus of control, so of course it's 1, no problem. And then the third thing that you need to check, and this is what you are going to support or reject your hypothesis, is the significance of the variable that you are analyzing, the locus of control. So the significance should be also below 0.1, like in here. So below 0.1, that's good. It means that locus of control is significant and it's positive. The relationship, the coefficient is positive. That means that the relationship is significant and positive. If your hypothesis says that there is a relationship between locus of control and happiness, and that relation is positive, then you can support your hypothesis based on this model. So it's 3 things that you need to check. You also need to report the R-square, because the R-square means how much of the variance of happiness is explained by the model. And right now, it seems that it's 8%. It's still okay because of happiness is very complex. And of course, we cannot explain all the happiness in one model. That would be crazy. But as long as it's not 0 or something like that, we can move forward. Or also, as long as it's not super high, like 90 or something like that, 90%, then we can move forward. So that's the first model. Then let's do the second model. The second model, we do the same, the regression linear, and now we're going to add the variable, the controls. So student, feminine, blah, blah, blah. And it should be like this. And then we click OK. And we do the same thing. So first, the model fit. The model fit is fine. It's not as excellent as before, but doesn't matter. As long as it's below 0.1, the model fit, it's okay, it's significant, and we move forward. The next thing is the multicollinearity. We are fine. It's not more than 4. And then we check the significance of our variable locus of control, and is significant, and is also positive. We check the R-square, and it's still fine, 8%. So the conclusion from model 2 is that the model fit, there is no multicollinearity problem, so we can interpret that there is a significant relationship that is positive between locus of control and happiness. So 2 models. We now need to do the third model. You go to regression, linear, and then the third model, we ask you to include all the other variables as if there were controls. So now you have everything in there, and you click OK. And we do the same. We do the test. So significance is fine. We don't have multicollinearity issue. That's great. And the locus of control is not significant. It is higher than 0.1. That is quite surprising. So we conclude that in this third model, we reject the hypothesis in this third one. So the overall conclusion, we can say that we found mixed results because model 1 and model 2 were okay, but model 3 is declined. So we can say we found mixed results where we partially support the hypothesis because it's 2 out of 3. So that's the general conclusion. So you do that for everything, all the variables depending on what you're doing, you do the tests and then you see, and then you analyze. It can be the possibility that everything works and then it's just full support, or nothing works, full rejects, or mixed results. There are many different combinations. Before I finish the video, what happens if the model fit or the significance is higher than 0.1? Well, if that happens, you full stop. You say, this model doesn't work, we cannot do anything. You don't even interpret. You cannot reject or support. You say, doesn't work, and that's it. What happens if you have more than 4 in the bias? What happens if you have multicollinearity? Well, what you have to do is to check which is the variable that is higher than 4, and you will probably need to take out that from the model because that variable is creating problems. So that's how you solve it. And then, of course, how do you, the other thing about the significance is just interpretation. Is it significant or not? And is it the relationship we're expecting, positive or negative? And that's how you support or reject. So I hope that it is clear that you know how to make it work and that you will be able to do your statistical analysis.